In section 3.2, let's find the x and y intercepts. The x-intercept is the point where the graph crosses the x-axis. In this case, we have the x-intercept is the point -3, 0. That's where it crosses the x-axis. For the y-intercept, that's the point where the graph crosses the y-axis. And in this case, this is the point 0, 6. The y-intercept is 0, 6. Let's look at example 2 now. In example 2, the y-intercept is where the graph crosses the y-axis. This is the point 0, 5. That's our y-intercept. Now for the x-intercept, that's the point where the graph crosses the x-axis, and that's going to be here at 1, 0. The y-intercept is 0, 5, and the x-intercept is 1, 0. In example 3, the y-intercept is this point, which is located at 0, 2. Now, where is the x-intercept? Well, when does it cross the x-axis? In this case, it does not. So, the x-intercept, well, we're going to say none exists, because it doesn't cross the x-axis at all. So, there's no x-intercept. Now, if you look at our examples, there's a commonality between them. Notice for the x-intercept, the y-coordinate is 0, and for the y-intercept, the x-coordinate is 0. And that's the case for all of the intercepts. Let's look at example 2. Again, for the y-intercept, the x-coordinate is 0, and for the x-intercept, the y-coordinate is 0. So that's a good way for us to figure out the x and y-intercept. Let's do that in our next example. In example 4, to solve for the x and y-intercept, we have to do two things. For the x-intercept, we'll let y be equal to 0. For the y-intercept, let's let x be equal to 0. Let's try the left side. We're letting y be equal to 0 now, so that's 4x plus 5 times 0, and that's equal to -40. This cancels out, so 4x is equal to -40. And now I can divide both sides by 4 to solve for x. X is equal to -10. That means our solution is -10, 0. That's our x-intercept. When you write your x-intercept, make sure you write it as an ordered pair. Our x-coordinate is -10 and our y-coordinate is 0. For the y-intercept, let's let x be equal to 0. So it's very similar to the other side, except we're letting the other variable be equal to 0. 5y is now equal to -40. I could divide both sides by 5, and so y equals -8. Remember to write your solution as an ordered pair. Our first solution is 0 for the x-coordinate, and our second solution here is -8. So our ordered pair is 0, -8. Again, when you represent your answer, write it as an ordered pair. 0, -8 for the y-intercept, and -10, 0 for the x-intercept. Example 5, same process, except we'll have to deal with the fractions. What I recommend that you do is get rid of the fractions first before you even start the problem. So let's look for the LCD. And what is our LCD? Well, we have 9, 12, and 3. So what number is divisible by all 3? Well, that's 36. And you could get that from guessing or using the prime factorization. So let's multiply 36 to everything, and then we'll simplify. 36 times 2/9, if you reduce that, that's going to give you 8x 36 times 1 over 12, if you reduce that, that's going to give you negative 3y, and that's equal to, if I reduce this one, I have 12 times 2, which is 24. So this is a much nicer equation than the previous one. It doesn't have any fractions in it. That means I picked the correct LCD. Now we can solve for the x-intercept. For the x-intercept, you let y be 0. For the y-intercept, you let x be equal to 0. For the first case, obviously the y is going to cancel out, so you'll just simplify it as 8x equals 24. Divide both sides by 8. X equals 3. And again, what do? We have to write it as an ordered pair. 3, 0 is my x-intercept. For the other side, if x is going to be 0, well, the 8x is going to disappear on us. So we'll just have negative 3y equals 24. I can divide both sides by negative 3. And so y equals negative 8. That means our ordered pair is 0 for the x-coordinate and negative 8 for the y-coordinate. It's 0, negative 8. Example 6. You can try this one on your own if you would like. Again, for the x-intercept, you let y be equal to 0. For the y-intercept, we let x be equal to 0. So let's try this out. We're going to replace that y with a 0. Well, that negative 4y, that's just going to disappear. So that simplifies to 3x equals 18. And so I could divide both sides by 3. X equals 6. And that means our x-coordinate is 6 and our y-coordinate is 0. That's our x-intercept, 6, 0. For the other side, we're letting the x be equal to 0. That means the 3x is going to disappear this time, leaving us a negative 4y equals 18. If I divide both sides by negative 4, that tells me y equals 18 over negative 4. But we could reduce this. Let's divide the top by 2, you get a 9. And divide the bottom by 2, you get a negative 2. So this actually simplifies to negative 9 over 2, which is okay. Our y-intercept now is the point 0, negative 9 over 2. And that's our y-intercept.